Chapter 12, Lesson 4, Shape of Data Distributions. You will be able to describe a data distribution by its center, spread, and overall shape. Data that are evenly distributed between the left side and the right side have a symmetric distribution. The distribution shown has a cluster of several data values within the interval 10 to 12. So here, between 10 and 12, most of the data is clustered. The gaps, 9 and 13, have no data values. So there's a gap between 8 and 10, and a gap between 12 and 14. The value 10 is a peak because it is the most frequently occurring value. Describe the shape of each distribution. The line plot above shows temperature in degrees Fahrenheit in a city over several days. So if I were to draw a vertical line anywhere on this graph, it would not be the same between the left and the right. So I would say that this is not symmetric. So let's write that in. This would be not symmetric. Okay. Clusters. Well, if we take a look here, we have some clusters here. Let me get the highlighter. We have a cluster here, and we have a cluster here. Okay, that includes all of this data. Okay, so I can say that both are clusters. So let's jot that down as well. So the clusters are from 16 to 18 and 22 to 25. There are some clusters. Gap, it has a gap right here. Okay, so our gap is from 19 to 21. Outliers, you would see outliers way off to one side or the other. And since I have nothing that appears that way, there's no need to go through all the calculations. So I would say there are none. And the peak, the highest point here, is 22. The box plot shows the number of visitors to a gift shop in 1 month. Because it's a box plot, you cannot identify gaps, peaks, or clusters. Okay, now symmetry, I would definitely say it's symmetric. So I can draw a line, oh, that's a little thick. I can draw a line right down the center, and it's the same on both sides. So I would say that this does have symmetry. So this is symmetric. And again, outliers on a box plot generally would be way out there, stars or asterisks on either end. And since I don't see any, and it's relatively, and because it's symmetric actually, we would say there are no outliers. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution below. Okay, if I were to draw a vertical line anywhere on here, it would not be the same on either side. So this is not symmetric. Cluster. Honestly, I can see a cluster in this area. So I would say the cluster is between, looks like minutes and seconds. So I would just say 0, 0, 1 to 7, 30. And this is minutes. Okay. And gaps, I don't see any gaps, so no gaps. There are also no outliers. If there were outliers in this histogram, you would see a big gap and then a bar way off to either the right or the left, and I do not see that. And the peak is within this interval. So from 0 minutes 1 second to 2 minutes 30 seconds. Now, we can use this flowchart to decide which measures of center and spread are most appropriate to describe a data distribution. If there is an outlier, the distribution is not symmetric, usually not symmetric. So, is it symmetric? If it is symmetric, we will use the mean as the measure of center and the mean absolute deviation as the measure of variation. If it is not symmetric, we will use the median and the interquartile range. So we don't have to find everything. We only have to find two things, one measure of center and one measure of variation. So the line plot shows the number of states visited by students in class. Choose the appropriate measure to describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Write a few sentences describing the center and the spread of the distribution using the appropriate measure. So the first thing we need to figure out is it symmetric? If I draw a vertical line anywhere on this graph, it will not be the same. So this is not symmetric. So let's write that down. Data is not symmetric. Therefore, we will use let's go back to our flowchart. Not symmetric, we're going to use the median and interquartile range to describe the data. Therefore, the median and IQR best describe the data, or best describe it. Okay, so that's what I'm using and my justification for it. That answers right here. Justify your response based on the shape of the distribution. We chose our appropriate measure. Okay, that takes care of that chunk. Now write a few sentences describing the center and spread of the distribution. Well, we have to actually find them. So let's list our data from least to greatest. 10, 10, 10, 11, 11, 5 times. 12 is 6 times. 13, 14, and 19. There's 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 data. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so let's go ahead and find the median and interquartile range. Well, in order to find the median and the interquartile range for that matter, we should probably find our minimum and maximum as well. So the min is 10. The max is 19. Let's go ahead and find the median. So the median is 12. And our interquartile range, we need to find our quartiles. So this is quartile 1. And let's do the same to find quartile 3. There we go. So to find the IQR, we need to take our quartile 3 minus our quartile 1, and we get an IQR of 2. Okay. All right. The median is 12 states. The IQR is 2 states. Okay. And now let's describe it here. The data are centered around a median. Well, we don't have to say that. Are centered around 12 states. The spread of the data around the center is 2 states. Okay. Letter B. Describe the center and spread of the distribution. Justify your response based on the shape of the distribution, then describe the center and spread. So if I were to draw a vertical line, I could actually draw it right here, and it would be the same on both sides. So I would say the data is symmetric. Since the data is symmetric, I'm going to use the mean and the mean absolute deviation. So the data is symmetric, therefore the mean and the mean absolute deviation best describe it. Now let's find the mean and the mean absolute deviation. Well, to find the mean, we need to add all of these numbers up and divide by the total amount of numbers. So let's grab a calculator and add them up. 25 plus 26 plus 26 plus 27 plus 27 plus 27 plus 28 plus 28 plus 28 plus 28. 29 4 times plus 34 times plus 31 3 times, then 32 32. Oops. Okay, so plus 31, I lost a little bit on my calculator here. 3 times plus 32 plus 32 plus 33. And then we are going to take that amount and let's see, let's divide it by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 18, 19, 20, 21, 22, 23, 24. So we had a sum of 696 for our mean. Our mean equals 696 divided by that 24 gives us 29 as the mean. Now, once we have the mean, we need to find the mean absolute deviation. So to find the mean absolute deviation, oops. Okay. We are going to take the absolute value of every data subtracted from the mean. And remember, put your largest number first. So 29 minus 25 absolute value. And I'm going to go ahead and write them all first. You know what? Actually, there's an easier way we can do this. Let me show you here. Because we have a line plot, there's a way we can do this with not so much writing. We know that the mean is 29. So 29 right here is the mean. I'm going to draw a line through that. That's the mean. So you want to find out how far away each data value is from the mean. Well, the x's that are on 29 are right on the mean, and there are 4 x's. So I'm going to say these are all 0 spots away from the mean. Let's go to the left first. 28 is 1 away from the mean, and there are 4 of them. So 1, 1, 1, 1. 27 is 2 spots away from the mean, and there are 3 of them. 26 is 3 spots away from the mean, and there are 2 of them. And 25 is 4 spots away, and there's only 1. Now let's go to the right side. The mean again is 29. 30 is just 1 away from 29, and I have 4 30s. So 1, 2, 3, 4. 31 is 2 spots away from 29, and there are 3 of them. 2, 2, 2. 32 is 1, 2, 3 away from 29. And 33 is 4 away from 29. Now let's find the average of these numbers. So let's add them in the calculator. 4 plus 3 plus 3 plus 2 plus 2 plus 2, plus 1 plus 1 plus 1 plus 1, plus 0 plus 0 plus 0 plus 0, plus 1 plus 1 plus 1 plus 1, plus 2 plus 2 plus 2, plus 3 plus 3 plus 4, gives us 40. And again, divide that by the 24 numbers that we, or 24 numbers that we have. So mean absolute deviation, we get 40 divided by 24. And let's round to the nearest tenths place. We get 1.7. Okay. So let's now describe it. We have our mean and our mean absolute deviation written out. So we can say the spread of the data around the center. Oh, wait, hang on. The data, forgot about the mean. The data are centered around the mean of 29 years, period. And the spread of the data around the mean is about 1.7 years, which is the mean absolute deviation.